了一下，让它在上面标一下，行吗？
All right. Hello, everyone. Thanks for coming to this class. So excited to have you all. So I hope everyone is ready, right? So my name is Michael. I'm a teacher from Upper Forest Hills Education. So today we're going to use 1 hour, very short, to give you a very brief introduction to what mathematics is like in Singapore, right? So today we're going to focus on grade 3, first semester of grade 3 in Singapore, right? So we call 3A. So I know a lot of you are at grade 3. So if you're at grade 3, the materials, the topics that we're going to see today, you probably have seen them before. But for some of you, maybe the Singapore Math 3A is what you are going to learn in grade 4 in public schools in Canada, right? So especially as we get to challenging topics, right? The difficult topics in 3A Singapore is equivalent to grade 4 in Canadian public schools, right? So because we have only 1 hour, guys, we're basically squeezing an entire semester into 1 hour, right? So if you are not able to catch up with certain things, or if you're stuck with a little problem, do not get dismayed or frustrated. This class is only meant to be an introduction. I'm just letting you know what topics are there for Singapore 3A and what's the main mathematical methods and main strategies and conceptions are for Singapore 3A, right? Okay, so let me start with telling you what are the main topics in Singapore mathematics, right? So this is an introduction to Singapore math, level G3A. G3, so grade 3, first semester. So these are the main topics, right? So at first, just like grade 2, we want to start with basic numbers, right? In Singapore grade 3, we're going to learn numbers up to 10,000, right? So not just hundreds, but thousands, right? So probably you are going to learn a question like, what is 9,054 minus 2,033, like that? And there are also small topics under numbers to 10,000. For example, what's the expanded form? And what is the standard form of a number, right? Take number 23, for example. 23, that's the standard form, just the number as it is. But if we expand 23, it's being expanded as 20 and 3, right? So 20 plus 3 is the standard form. We're also learning rounding numbers, right? Why do we round numbers? We find it's easier to remember we round numbers. So that's the main things for the first topic, right? First topic. Now the second topic is addition and subtraction up to 9,999, right? So it's a daunting number, but as long as you know how to add and subtract, for example, 11 and 44, then you will know how to add and subtract up to 10,000. Right? Under the main topic of number 2, add and subtract, we'll introduce a very important mathematical method, right? A method. It's called model join, right? How to use model join to solve complicated word problems. A lot of students find word problem pretty dry and hard to understand, right? Because it's all boring English words. Model join, we draw bars, right? Not fashion models, right? We draw bars to help us understand better, to help us visualize the word problem better, right? So it's a very important thing that we are going to introduce in Singapore 3A. Now, after addition and subtraction, we're going to do multiplication and division, right? It's like building a house. You start with the basement, right? That will be numbers to 10,000. And then you build the first floor, addition and subtraction. And now, after that, we go on to multiplication and division. So, if you're in grade 3 in Canada, probably the multiplication division you're learning maybe is below 50. So probably like 4 times 5 or 10 times 7, right? But for Singapore 3A, it's going to be up to 999. So you are going to see questions like, what is 145 times 3? Okay? What is 600 divided by 3? Right? So it's going to be involve some big numbers, right? So topic 1, 2, 3 make up a big chunk of Singapore 3A. And then we still have a little bit time left. There will be a small topic called length, right? Basically a review of what is meters, what is centimeters, and how to change meters to centimeters. All right, so let's start with the first topic, number to 1 to 10,000. So the first important concept about yeah, do you have a question?
May I please go to the bathroom? It's very quick.
Yeah, sure. Go ahead. So standard form and expanded form, right? I want you to imagine in your head a toy you played before, right? I want to imagine a slinky toy, right? A slinky toy. This is not the actual slinky, but I made it in paper, right? A slinky, you can compress it to be very short, but you can also expand it to be very long, right? Same with numbers, right? We can expand the number to be big, right? How do we do that? We take the digit out and we find the values for each digit. Okay? So let's start with a short number. Let's start with this number 357. Right? 357. This is called standard form, right? 357 is just a standard form. So standard form, remember, is just the number as it is, right? Now, expanded form, right? Same with slinky, we can expand the number to be long, right? So before we do that, we need to figure out what's the place values for each of these digits, right? The number 3 is in the hundreds place. So what really stands for is a 300, right? The number 5 is in the tens place. So what that stands for, so 5 is actually a 50. 7 is in the ones place. So 7 is just a 1. Now we have expanded the number, right? We take each digit, we pull each digit apart, and we find their respective values. If we add them, $300 plus 50, and then plus 7. This is called the expanded form of 357. Okay? So we say 300 plus 50 plus 7 is the expanded form. So basically, expanded form, you take each digit, you pull each digit apart, and you figure out what's their respective value, right? Very simple, expanded form, standard form. Let's look at another example. This time, we're going to use 4-digit number, right? So up to thousands. Let's take 4,685, right? So this is a 4-digit number. So the highest place is going to be the thousand. Right? Standard form is just as the number it is, 400,685. This is the standard form. Now let's do the expanded form, right? Get ready to expand. Right? So the first digit 4, right? The first digit 4 is in the thousand place. Right? So what that really means, the 4 really means it's a 4,000. Now let's move on to the next digit, 6. 6 is in the hundreds place. So 6 is really only a 600. Next, 8 is in the tens place. So 8 is a 80. Lastly, 5 is in the ones place. So 5 is just a 5. Now we have expanded number. If we add them together, that becomes our expanded form. 4,000 plus 600 plus 80 plus 5 is our expanded form, excuse me. Expanded form. Okay. So far, so good, everyone. Okay, so let's move on to do some problems. Okay, let's start with number 2. All right, so that's expanded form and standard form. Okay, let's look at this number 5, question number 5. Which does the digit 5 stand for in each of the following numbers? You can see A, B, C, they are both 4-digit number, but the number 5 comes in different places. In part A, the number 5 is in the hundreds place, right? It's in the hundreds place. So the number 5 here,
Thousands.
yes? Do you have a question?
No.
No? Good. So the number 5 in A, it stands for, so in this case, 5 stands for 500, right? Because it's in the hundreds place. Now let's look at B. In part B, 5 is in the thousand place. So this 5 stands for 5,000, right? 5,000. Let's look at part C. In part C, 5 is in the tens place. So for part C, 5 stands for 50, right? 5 stands for 50. Right? So do not answer and say 5 stands for hundreds or thousands or 50, right? Say their respective values, right? Say their respective values. Okay. Okay, let me bring this. All right, that's okay. The next thing is to compare numbers, right? Compare numbers, right? So, for example, 316 and 264. Let's compare them. How do we compare two numbers? We compare two numbers by comparing the first digit first, right? They are both in the hundreds place, right? So we know 300 is bigger than 200. So we know right away that 316 is greater than 264. That's when the first digit is different, right? Now let's look if the first digit is the same. For example, 325 and okay, my screen is a little bit problematic. Okay, now if we were to compare 325 and 352, still we would like to compare the first digit, right? The first digit is 3, right? 3 in both numbers, right? When the first digit is the same, we move on to the next place. Right? So now we compare 2 in the tens place versus 5 in the tens place. We know 5 tens must be bigger than 2 tens. So we know 325 must be smaller than 352. Right? So whenever you have the same digit on the first, same value for the first digit, you move on to the next place on the right. So we are going over very quickly, right? It's probably gonna take us in real class, maybe a month to learn, but this one, we're talking about it in one single class, just to give you an introduction.
Michael, excuse me, Michael.
Yes?
Yeah, Michael, besides introduction for the whole term semester, the contents cover, do we have an exercise for the students to try with you today?
Yes, I can certainly give some. Do you mean
do you mean right now in the trial classes? Not only we let them be a participant to try a little bit. We instead of we run through all the contents, right? There will be more fun for the students. They want to try.
Okay, sure. I'll give some exercise.
Yeah, don't worry about time. If 10 minutes longer or later, that's okay.
All right. Okay.
Thank you.
Okay. So let's try a example for the expanded form and the standard form, right? That's our first topic. So let me write down. Right? So can you guys write down the expanded form and standard form for the following number? Let's first start with a hundreds number, right? Let's try 278, right? Can you guys tell me what is the expanded form and what is the standard form? Anyone? Yes? You. Right, so let's start with...
I thought I was going to type it.
Sure. So, right, I'm not hearing anybody. Okay.
I'm not finished with my typing anyways.
Standard form
Yeah.
for 278.
Good.
2 is for 200 plus 70 plus 8.
Very good. Very good. So standard form is just as the number as it is, 278. Or as the expanded form, you need to expand it, right? So that's 200 plus 70 plus 8. Very good. Expanded form. Okay. Okay, let's do another example about comparison numbers. All right, let's compare two numbers in their thousands, right? Part A, right? Which is greater, 4,316 or 4,264? Which one do you guys think is bigger?
4,316.
Very good. So
That is what I was going to say.
Very good for you too. 4,316 is bigger than 4,264 because we have the thousands place being the same, so we compare the hundreds place. 300 is bigger than 200, right? So the first number is bigger than the second number. Very good. Glenna, you raise your hand. Do you have any input?
No, I also want to do the second part.
Okay, sure.
I am ready.
Sure, can you tell me your answer for the second part?
Yes, the second part of A is 5,264.
Yes, so that is greater, right? So we say 5,264 is bigger than 4,316, right? because the
And
first.
also, I want to show everybody how I did it.
Sure, show
4 is
everyone.
smaller than 5, and that's why.
Yes, we compare the first digit, right? 4 is smaller than 5. So we know right away the number 4,316 is less than 5,264. Very good. Okay, I'm sure everyone else is able to get this conclusion, right? Okay, not too difficult. Okay, so that's for some exercise for expanded form and number comparison. Okay, next, let's talk about number patterns, right? Whenever we play numbers, we want to find their relationship between numbers, right? Pattern, what do you mean by patterns? If there's a pattern among the numbers, there's a common relationship for all the numbers, right? 1, 2, 3, 4, 5, up to 10, that's a pattern. What's our pattern? Every number is increasing gradually by 1. Right? 10, 9, 8, 7, up to 0 is also a decreasing pattern. Right? So let's find a pattern. Let's complete the pattern for part A. Okay. So before we find patterns, we have to look at the numbers very carefully, right? So we start with this number 5342, and the next number 5442, and the next number 5542, right? If you look closely, every number behind is always one more 100 than the previous one, right? So Faye, you raise your hand. Do you have any input?
I was going to say that each one is like adding 10.
Be careful. Are we adding 10 or are we adding 100?
Oh, I mean hundreds.
Right. If you look at the bold number 3, 4, 5, that's in the hundreds place, right? So our pattern is the hundreds place are increasing by 1. So if we follow this pattern, Faye, what's the next number that appears? Yep, that you circled in blue. What should be the number in blue?
The next number is 5,642.
Good. So it should be 5,000, now 642. Okay. Anyone can tell me what should be the next number?
It's 5,742.
Very good, right? The hundreds place are increasing by 1 each time. Right? So that's the pattern for A. Let's do another pattern. Let's do part D, right? Part D. Big numbers, right? Let's see, we will be able to find the patterns, right? If you look at the bold, right? Somebody already underlined the bold. If you see closely, the bold numbers, they are all in the tens place, right? 5 is 1 more than 4. 6 is 1 more than 5. So for the tens place, we're increasing by 1. So can anyone tell me what's the next number? Anybody?
5,372.
Good. 5,372. And what should be the next number? Anybody? What's the next number?
5,382.
Good. I heard 2 voices. They're both correct. 82. Very good. So these are 2 basic finding patterns questions, right? Okay, let's move on to the next one. Okay, the next small topic is called rounding, right? First, let's see. I don't know if you guys have seen rounding numbers before, but what do we mean by the word rounding? Yeah, Glenna, what do we mean by rounding?
Rounding things like a number that is close to a 10-digit or 100-digit or any number that has zeros on it, such as 99 rounds up to 100 and it also has zero.
Right. So rounding, we can say, is about estimating a number, right? We're about to estimate, right? Estimate, right? So a question here: if we know a number is 999, why do we bother to estimate? Why do we bother to round them? Isn't it more work if we choose to round numbers? Why can't we just use number as they are? Anyone, any idea? Why do we care to round numbers? So if you look at this savings example, we have 3 girls, right? Maggie, Brandy, and Rosa, right? So their exact amount of money is that Maggie has $61, Rosa has $68, and Brandy has $75, right? If they tell people, Mandy said, I have 61, Rosa said, I have 68, Brandy says, I have 75. These numbers are too specific, right? They're too detailed. It's not easy for people to remember. Instead of Rosa saying, I have 68, Rosa just said, I have about $80. Do you guys think $80 is easier to remember than 68?
Yes.
Yes, right?
Yes.
It's easier, right? So instead of Brandy say it's $75, Brandy can just say, I have $80, right? So 80 is easier to remember, right? So the first thing, right, before we do rounding, let's understand why do we round, right? Why do we round? So let's write it down. Why do we round? As I said before, right, 2 reasons, right? It's just easier. Right? It's easier to remember, it's easier to write, right? Second thing, it's just simpler. It's simpler. 80 is simpler than 84, right? Everybody likes numbers that come with tens. That's just easier to add, easier to remember. Okay. So that's why we round numbers. So next, let's talk about how do we round numbers, right? I know probably some of you know already how to round up to the hundreds place, but because we have 10 students, right? We have 10 students, we want to start with the tens place first, right? So let's start rounding to the tens place. For roundings, remember, there will be strong numbers and there will be weak numbers. So strong numbers. Strong numbers are those numbers that push the number up, right, to the next tens. So these numbers are 5 and up. So we have 5, 6. That's right below that. We have 5, 6, 7, 8, and 9. These are numbers that are going to push the tens place to the next. Right? And then we also have weak numbers. These numbers are so weak, they don't have strength, they don't have power. So the tens place is going to remain the same. So these numbers are 4 and below, right? 4 and below. Why stop drawing, right? Drawing helps you understand better, right? Drawing helps you stop understand better. Right? 0, 1, 2, 3, 4. Right? These are numbers that are weak numbers, right? They are so weak, the tens place is gonna stay the same. Okay, so remember that, right? We have strong numbers and weak numbers. This applies to all the roundings, no matter to the tens place.
So the weak numbers are like the 3 and the 0?
Yes, right? So as you can see in this red box, weak numbers are 0, 1, 2, 3, and 4. Right? Strong numbers are 5, 6, 7, 8, 9. Right? Okay. Right? So the top is strong numbers, below is weak numbers. Okay, so let's use this to round some numbers. Right? We want to round it to the tens place, right? Let's start with 61. 61, who is in the tens place? 6. Right? If we want to round, all right, so who is drawing these arrows? Right? Let's stop drawing. Okay. Let's stop drawing. Let's listen to how we round. Right? So we want to round to the tens place, which is 6, which means we need to look at one place to the right. So let's look at the number 1. Right? This is the number 1 to focus on. Right? From before, we know weak numbers are 0, 1, 2, and 3, and 4. 1 is a weak number. So the tens place are not going to be pushed up. Instead, the tens place is going to stay the same. So 6 is going to stay a 6 in the tens place. And 0 and 1's place. So if you really want to draw, next we're going to introduce model drawing. You're going to draw lots of bars, right? So do not get too passionate. Let's wait till the word questions to draw, right? You'll have lots of things to draw that you'll be tired of. Right? Okay, so 61, we have rounded to 60. 60. Now, let's look at the next number, 68. 68, we round it to the tens place, which means we need to look at the ones place, right? One number to the right. 8 is a strong number. It pushes the number up. So the 6 is going to be pushed to the next tens, 7. And the ones place will be always 0. So 68 will be rounded to 70. Okay. Let's look at another number. Let's do 75. Anyone want to volunteer? What number will 75 round to? Yeah, Eric, did you raise your hand?
Yeah.
Yeah. Can you tell me? 80, right? Because we need to look at the number 5 in the ones place. 5 is a strong number. So it's going to push the 7 to be an 8 in the tens place. And the ones place will always be a 0. Will always be a 0. So 75 will be rounded to 80 instead. Okay. So that's round to tens place with a 2-digit number. Let's do some exercise, right? We still, look at number 3. We still want to round to the nearest 10, but we have bigger numbers, right? For example, A has 3 digits, right? 3 digits, but we still want to round it to the tens place. So let's look at 129. Right, so hear me out before we exercise, right? So we want to round to the tens place. That's number 2 there, which means we need to look at one place to the right, 9. We know 9 is a strong number, so it's really going to push the 2 to be a 3. Very good. And the ones place will always be a 0. But we still have a hundreds place, 1, right? But we don't care about 1 because we're only rounding to the tens. So the hundreds place will remain the same. So 129 is going to round to 130. Okay, now it's time for exercise. 201, which number are we rounding to?
109. 120, 201. Oh, I mean
200?
200, 200.
Right. So I heard
200.
right. At first I heard 190 something, and then I heard some people say 200, right? So one of them must be right. So let's do it. Right? Let's do it. 201, right? We want to round it to the nearest tens, right? So that's the digit 0 there, right? Which means we need to look at one place to the right, right? So let's stop drawing, right? Okay, thank you. Okay, we'll draw later, right? Which means we need to look at the ones place. The ones place is 1. 1 is a weak number. That means weak number means the 0 is going to stay. Okay? 0 remains 0. And the ones place always becomes 0. We don't care about the hundreds place because we're not rounding it. So the hundreds place remains the same as 2. So 201 round to 200. Round to 200. Okay. Okay, let's do this one. Part F, 4,355. That's a number in the thousands place. Still, we want to round to the tens place. Can anyone tell me what digit is in the tens place?
4,355. 4,355.
Yes, that's our number that we need to work on, right? Can anyone just tell me which digit is in the tens place? Which digit is in the tens place in this number?
50? 5, which is like 50.
5 is in the tens place, right? So let's
5 is actually 50.
That's what we want to round, right? Tens place. If we want to round to the nearest 10, we need to focus on the ones place, right? One place to the right. 5 is a strong number. So it's really going to push the 5 in the tens place to the 6, right? And ones place always becomes 0. Right? But we still have the thousands place and hundreds place. Do we need to care about them? Not really. We're only rounding to the nearest 10. So the 4 in the thousands place and the 3 in the hundreds place, they are going to stay the same, right? 4,360 is what we're rounding to. Okay, so that's all for rounding numbers. Okay, so that's all for topic 1, numbers to 10,000, right? We did standard form, expanded form, compare 3-digit number, compare 4-digit number, and then we did some rounding, right? So these are the main topics. There may be other small topics, but not during this class. This is only meant to be an introduction. So now let's move on to the second topic, addition and subtraction. So for addition, subtraction, now it's time for us to draw, right? Now it's time for us to draw. So our focus here is about word problems, right? Word problems. Word problems is difficult for some students because it's kind of hard for them to transfer English words, transfer in boring English words to math, right? There's a transfer, there's a process of transfer. Think of you have some vegetables and chicken, right? You cannot do anything with vegetable and chicken. They are raw. You're not going to eat them. You need something to transfer them to delicious food in your plate. Okay? Then you need cooking oils, you need soy sauce, you need salt, and of course, you need a cooking pan, right? Same for word problems. We need something to transfer boring English words to math, right? But so what do we use there? Model joins, right? This is an important math method for Singapore 3A, model joins. Okay. So let's see, how do we write model joins? M-O-D-E-L, model, drawing, D-R-A-W-I-N-G. Okay. So model, we're not drawing a fashion model, right? We're not drawing in person. By model, we simply mean bars, right? Bars. We simply mean bars. We draw different bars. If a number is small, we draw a small bar. If a number is big, we draw a big bar. That's all we mean by model drawing, right? Okay. That's all we mean by model drawing. Okay. So let's look at an example. Can anyone volunteer to read question 4 for me? Question 4 here. Can anyone volunteer? Sure. This boy, can you volunteer with the hat? Can you volunteer?
So question 4 is 627 boys and 493 girls took part in a storytelling competition. How many children took part in this storytelling competition altogether?
Right. So whenever we do word problems, right, we want to underline the important information, right? Let's see what is considered important. We have 627 boys. That's very important. That's a number we are going to work on. So let's underline that as important. And we have some girls, very good, 493 girls. Right? Now the question is asking how many children, right? Children is an important word. Children means we have both boys and girls together for children, right? So whenever you read children, you know right away it's talking about both boys and girls. Right? Okay. So we need to fill out this blank. How many children took part in the storytelling competition? Okay. As I said before, model drawing helps you understand better. So let's draw a model. So let's draw a model. First, we have 627 boys. So let's draw a bar that represents boys. So let's draw a bar here. This represents boys, right? All right, so we can draw, how about we draw after class, right? Let's draw after class. So the first bar is boys, 627 boys. And then we have another bar that must be for girls, 493. You know, 493 is smaller. That means the bar will be also shorter. Shorter.
And thicker a little bit, I guess.
Right. Okay. We want to know how many children took part in the storytelling, right? We know children is both boys and girls, right? So children can be boy or girls. So children, if you think of your number bound, children is the total. Children is the total. Boy and girls are the part. Right? Boys and then girls. Then in order to get children, we must add boys and girls together, right? So we can say children, number of children, that equals 627 boys plus 493 girls. Now we're going to add a 3-digit number to another 3-digit number, right? Okay, so let's add. We wish to put the big number on the top, 627. And now let's put the small number on the bottom, 493. So be careful. Numbers, they have places. One's place must align with one's place in a straight column. Tens place must align with tens place in a straight column. And same for the hundreds place. Right? So let's put 493 below that, right? 7 and 3 must be aligned because they are both ones place. 2 and 9, tens place in the column. 6 and 4 in the same column because there is no hundreds place. So now let's add. Okay. Whenever we add, we want to start with the ones place. 7 plus 3, that's a 10. But we cannot fit a 2-digit into the same place. So that we have the 1 that will be carried over. And that's left with a 0 in the ones place. Now let's move on to the tens place. So in the tens place, we'll have 2 plus 9, that's 11. But we still have a 1 to add. So that'll be 12. Again, the 1 carries over to the hundreds place. Now let's move on to the hundreds place. 1 plus 6 plus 4, that's 11. So we can say the number of children is just 1,120. So let's fill in the blank. Let's fill in the blank. 1,120 children took part in the storytelling competition. Okay. So you can see, why do we bother to draw bars for this simple question, right? Because whenever we introduce a new concept, model drawing in this case, we want to start with small, right? Small concept eventually gonna grow big and help you solve complicated problems, right? We'll see one more complicated question later. Okay, so anyone can want to volunteer reading question 7? Anyone? Yes, please.
Me?
Yes, go ahead.
Okay. So I loaned didn't even know
Question 7.
Okay. After spending $134 on the table, Claire had $265 left. How much did she have at first?
Okay, so remember, first step for word problem, we want to underline important information, right? So let's read. 134 is important. That's a number, right? Claire had 265 left, right? That's the money that she had remained in her pocket. How much did she have at first? We want to find how much did she have at first, right? So in your head, imagine Claire, she had a lot of money at first. So she chose to spend 134 on the table. After she spent them on the table, she still had some money left, right? We want to find how much she had at first as a rich person. Okay. As we said, we're going to use model drawings, right? We're going to use model drawings. Let's draw the bar that she had at first, right? This is the bar she had first, at first. All right, so let's see what happens to her money. She spent 134 on a table. So out of the money she had first, part of it goes to the table, right? Let's do a bar and shade the table as, let's shade the table as brown, right? Maybe she brought a brown table. Let's shade it as brown. Okay. So the brown shaded area is for table. Okay. So let's denote that. That's 134 for table. Okay. Then the leftover white area will be how much she has left, right? So the white area, this area will just be how much she has left. According to the question, she has $265 left, right? Okay. And the whole thing, the whole bar is how much she had at first, right? at first. Okay, so you can see this is very clear if you use model drawings, right? At first, you have a big bar. The big bar has a part that is how much is left and the other part that she spent on the table. So obviously, we need to add the two numbers together to find how much at first, right? It's very clear, right? Two parts together will make the whole part. Right? So at first, right, somebody already wrote that, so that's correct. So we can say at first, you need to add 265 plus 134. Right? So let's add that. 265 plus 134. Put a plus sign, join line. Now let's start from the ones place, right? Ones place, we have 5 plus 4, that's a 9. Then tens place is a 6 plus 3, that's a 9. And the hundreds place is 2 plus 1, 3. Right? So she has $399. So let's fill in the blank. She had $399 at first. $399 at first. Now, if somebody don't know how to use model drawing, this question can be quite confusing for them, okay? Because the relationship between how much is left and how much she spent on the table, it can be confusing without the use of pictures. Okay, maybe we can do 1 or 2 more questions with 3 more minutes.
Okay.
Okay, since we only have 3 minutes left, we haven't even gone to multiplication. So we're going to use model drawing to solve one multiplication problem, right? Let's solve one multiplication problem. Remember, multiplication is always about adding equal groups, right? Adding equal groups. So you have 2 groups, each group have 5 cards, then you can use 2 times 5 equals 10, right? Multiplication is commutable, which means 2 times 5 is the same as 5 times 2. Okay. Let's use model drawing to solve a multiplication word problems. Okay, this is the problem. Harry has $36. He has 4 times as money as his brother, right? How much money does his brother have? First, we need to find who is he. He, does it refer to who? Glenna, who is Harry? Who is he? Good, you circled Harry, right?
Harry.
Good.
I didn't circle that. Someone else circled that. I didn't get the chance.
Okay, but you answered correct, and somebody else also answered correct, right? So we can say Harry has 4 times as money as his brother, right? So let's do a bar for Harry. This bar is for Harry. And he has $36. Harry has $36. If Harry has 4 times as much money as his brother is going to only have a quarter of money, right? A quarter, like that much. Right? Basically, you want to divide Harry by 4. Okay? and 1 out of the 4 will be his brothers. So the bar below will be his brother. Then from this model drawing, it's very clear. To get the brother, we have to use 36 divided by 4, right? Because Harry has 4 equal parts. So we can say brother is 36, right? Divided by 4, right? For my computer, I use / as division, but when you do your exam, please use the traditional way, a line with 2 dots. Now 36 divided by 4, right? We need to think 4 times what number makes 36? Yes?
9.
9, good, 9. So we can see his brother have $9, right? His brother has $9. This question is especially tricky for a lot of students. Why? Some students, when they look at the word 4 times, they immediately think, I have to use multiplication. Not the case, right? Not the case. We actually use division, right? So how do we make sure we don't make the mistake? If you use model drawing, probably it's much easier for you to see, right? It's much easier to see that his brother actually has a quarter of money, actually. So model drawing helps you understand the question better. Model drawing. Right? Again, right? Just because it says 4 times doesn't mean we have to use multiplication, right? Doesn't mean. All right, so that's one heck of a quick hour, right? So we covered mostly addition, subtraction, and numbers. We only did one question for multiplication, right? But at least we introduced the important mathematical method called model drawing, right? Draw bars and boxes for complicated word problems, right? So I hope by the end of today, you have at least some basic understanding of what's going on in Singapore mathematics grade 3, right?